Welcome. This is the last part of support reactions for simply supported beam with uniformly varying load represented by trapezium. Last part is numericals. See, first I solved a general question. I wrote W1 to W2, where W1, W2 no link. So it was little lengthy, but that question, I think that was question number 37, 34, 34. But that question will give you more information and give you more perfection if you understand that one. Because some simplifying terms you have to simplify, little careful you should be. Next I solved two more questions where I considered bookwork type only, not numerical, but instead of W1 and W2, I don't remember now, say 3W to 5W, W to 3W, that way. There, these two intensities are connected together. So, simplifying is much easier. Now, lastly, numericals. Majority of people, they are happy when numerical comes. So, after explaining all those questions, I think I don't have to explain much for numerical. So, briefly I will do. Everything I told so far, you should remember. Okay, start. Question 37, dictated as usual. Simply supported beam of span 10 meter, loaded by uniformly varying load of intensity 8 kN per meter at the left end, linearly increases to 20 kN per meter at the right end. Or they can tell simply support beam of span 10 meter, subjected to uniformly varying load, where minimum intensity is 8 kN per meter at the left end and maximum intensity is 20 kN per meter at the right end. Okay. Beam with given loading, usual story. From here, you have to come here now. Write the sketch, AB, VA, VB. Now, you should write, this is total load acting through centroid. Centroid, slightly this side. This question, slightly this side. Next numerical I am giving, see here. I am giving next numerical, I will put somewhere here, light, where space is there. My next numerical will be here more, here lesser. So slightly this side. Okay. The total load is equal to area of the trapezium. This all told many times. Those who are serious should write. And line of action of that load from here will be 8 plus twice of 20 divided by 8 plus 20 into 10 by 3. First of all, I should not have written this one. Okay, over. So, this is your option 1. I write here. This is your option 1. Option 1. That is, consider entire trapezium as single unit. Okay, start. Take moment about A. Minus VB into 10. Why my? These all I will not tell. Why it is minus means I don't know how many times I told it. So, minus VB into 10 plus the total load 8 plus 20 divided by 2 into 10 is the total load. Sorry, here. Actually, after the sketch, you first come here. See, after the sketch, first come here. I will put arrow mark here. First come here, then go that side. So, minus VB into 10 plus 8 plus 20 by 2 into 10 is total load into, from here, distance to line of action of the total load, that is through centroid, this distance. I wrote here. You can write, this is total load. This is that X bar I used to tell. X bar means distance of centroid from A. X bar from A. Okay. You will get VB equal to plus 80 kilonewton. Actually, I have not calculated. I applied the trick. Okay, no problem. You calculate. Sigma V0, upward positive, plus VA plus VB minus only load 8 plus 20 divided by 2 into 10 is 0. Substitute VB equal to 80 kilonewton. VA will come 60 kilonewton. This is option 1. Now, go for option 2. I write here option 2. Now, before that sketch, see, option 2 means, 1 minute, VA, VB. Span is 10 meter. Okay. Span is 10 meter. Now, when you write option 2, first you have to make some preparation, some statement you have to write. Remember, option 2 is for those who find area of trapezium is not a problem, but locating centroid, this they get confused. So many people, they want this option. Why? Sir, easy, sir. Okay, no problem. Then, see the original question. See here. Original question. 8 to 20. 8 kN per meter to 20. First you have to write this one. 20 kN per meter. Span is not required. This is A, this is B. This will be equal to, see, light line divide. Therefore, one rectangle and then one triangle this way. The rectangle will be 8. This will be 8. This will be 20. This is 8. This is 12. Why 12? 20 minus 8. Now, what you do is you stagger the arrow mark to show that one rectangle and one triangle. Now, see here. For rectangle, resultant force. Now after this one, you write this sketch. After this one, write this sketch neatly. See, resultant load will pass here to centroid. Exactly center. For uniformly varying load, resultant load will be somewhere here. That will be from here 2/3 of 10. That I won't write. Okay, now make a note. As soon as this question is over, I'll give next question, question number 38, where, see, this I will remove now. I will not tell anything there. See, I will just give question with the answer. Okay, in next question, now only I will tell you. In question number 38, I will give loading like this. Here more, here lesser. Okay, I don't know how much I am giving. Okay, maybe 40 kN per meter here. This is some, say anything, 16 kN per meter. Oh, it becomes exactly double. No, not leave it. Anything, say here, 30 kN per meter here. This is something like 14 kN per meter. And span is 6 meter. Okay. This I'll give. I'll remember now. When I give a question, I'll remember here, 30 to 14, span 6 meter. Okay, same I will give. I am explaining now only. When you do like this, centroid is here, no problem. You can do it. But when you divide into parts, see here, when you divide into parts, if you go for option 2, then at that time, once again you have to write it. This is 14. So that means you write here, this is 14 and this will be 30 minus 14 is 16. And now see here, centroid here, centroid here. Here, from A, centroid is at 2/3 of 10. But here, centroid is this side. It is not 2/3. Here it is 2/3. Here it is 1/3. That is the only change for next question. So, once I complete this first question, that is question number 37, happily solve question number 38. I will give question the direct answer. Okay. Now, start. You write all these at that time. Sigma m about A0, take clockwise positive. Okay. Minus VB into 10 anti-clockwise plus moment of this load. This is UDL, 8 kN per meter for 10 meter. So plus 8 into 10 is the total load multiplied by, it is passing here exactly center, 10/2 plus this load, half into 10 into 12. Half into 10 into 12. Why I will not tell, too late. Multiplied by, from here to here, I told 2/3 of 10 equal to 0. You will get the value of VB. $80 kilonewton. People will laugh. He is not calculating. He knows the answer. Okay, confidence. 80 kilonewton. Okay. Sigma V0, take upward positive. Plus VA plus VB. Why black? Red color. Black color will do. Plus VA plus VB minus this total UDL, total load, 8 into 10, no into now, total load, again minus this load. See, I told load half into 10 into 12 equal to 0. Substitute, okay, substitute VB equal to plus 80 kilonewton. Okay, unknown is VA, okay, red color. Therefore, you get the value of VA. No. Plus 60 kilonewton is the answer. See here, VB 80, VA 60, VB 80, VA 60. Correct. Over. Now, time for presentation. Lastly, actually presentation means what? That is called neatly completing. See, the presentation is important. Suppose you go somewhere, some work is there, some friend's house all. You finish everything. When you leave the house, what you tell? You tell, okay, see you next time. Thank you. That is some good gesture. Presentation, I always want the last presentation so that it becomes what? Systematic end for the question, not randomly leave somewhere. Because later, suppose you want SFD BMD, you have to continue that final presentation diagram. Okay, therefore, as usual, support reactions for the beam will be as shown below. See, when I do final presentation, I always put the original sketch. Dividing or not required now. See, this is A, this is B, here it is 8 kN per meter, linearly increasing to 20 kN per meter here. And then this is the load, uniformly varying load. The final reaction, VA equal to 60 kilonewton. And final reaction, VB equal to 80 kilonewton. See, little more reaction that side. Span is 10 meter. Okay, now, or you can go for shortcut as usual. Part 2, lecture 36. You have to write it. That means that class you have to refer. See, direct shortcut. See here. Eight kN per meter. Actually, writing is not required. You can refer there only. Okay, 20 kN per meter. Span required, I will put here 10 meter. Okay, first, through centroid, you require total load. Magnitude of total load. Don't put modal. Magnitude of total load equal to area of the trapezium 8 plus 20 divided by 2 into 10 kilonewton, or will be equal to 140 kilonewton. Now, this is A, this is B, this reaction VA, this reaction VB. Now, these two you want. See here, we want this distance. That distance is from here, 8 plus, excuse me, 8 plus twice of 20 divided by 8 plus 20 into 10 divided by 3. I already calculated there. It comes to 40 by 7 meter. You can go for decimals actually. 40 by 7 meter. Here, 5 point something will come. This distance is from here 20 plus twice of 8 divided by 20 plus 8 into 10 by 3. If that is 40 by 7, total is 7 is 35, 10 is 100. This is 30 by 7. It will come 30 by 7 meter. Or 4 point something. This will come 5 point something. You can go for decimals. This is more accurate. Okay, now over. VA equal to total load 140 into other distance 30 by 7 divided by span 10 equal to Y. Calculate. It has to come 60 kilonewton. VB equal to total load, where is total load? 140 kilonewton into, if you want VB, other distance 40 by 7 divided by 10, it will come 80 kilonewton. Over. This is complete. Now, I will conclude this class because this is the end of uniformly varying load. Next, we are start couples. Couples, I want to start fresh class. Lot of principles are there for couple. Therefore, I will write somewhere here. You can do whatever you want. You either apply trapezium as with the centroidal location, or divide into rectangle and triangle, or you go for the shortcut, do by all the way for thorough practice. I remember now what I told. The question number 38. So next is question 39. I'll make a note here. Couple question 39. I'll forget it. Okay. Therefore, next question. Simply supported beam of span, this is I will call A and B, this is for my reference, of span, how much I told there? Some span I told, I rubbed it out. 6 meter, it is there. 6 meter. 6 meter is loaded by uniformly varying load where maximum intensity is at the left end equal to 30 kilonewton per meter. 30 kilonewton per meter. And minimum intensity is at the right end, that is 14 kilonewton per meter. Okay, this way it will come. Okay. Find vertical reaction. So answer. Your VA equal to and VB equal to. Correctly work out the question and get the answer. Divided by 3 plus 20 into 10 divided by 6. Calculator is not on. 8 into 10 divided by 3 plus 20 into 10. No, sorry, I'm seeing this question. I will get once again that answer only. I should see this question. Okay. 30 into 6 divided by 3 plus 14 into 6 divided by 6. 74 kilonewton. I am applying some trick. I know so many tricks here. I am applying one of the tricks which I like. 74 kilonewton. VB 30 into 6 divided by 6 plus 14 into 6 divided by 3. 58 kilonewton. If I add those two, 58 plus 74 is 132. Correct answer? 30 plus 14 divided by 2 into 6 is 132. Okay. This is the answer. Okay. I'll wind up the class. Again, as I told you, I am continuously recording because around 1 week or 10 days, I may not be in station. So, as much as possible classes I want to record now and store it. So, even from my native place, I can release one by one class. Okay. Therefore, marathon class I am taking. Okay. Now I'll go for next question number 39. Very important next class, couples. Lot of principles are there. I will explain. Okay. Thank you.